Welcome back. This small video lesson is going to be about growth rates and inflation rates of the economy, and we'll be focusing on how to calculate that. So by the end of the video, you should be able to differentiate between real and nominal values, or you should be able to calculate GDP growth rates, and you should be able to use the deflator method to calculate inflation rate. So before we start, we want to talk about GDP once again. In the previous video, we said that GDP could be calculated using three approaches. The first one was the output approach, and that was to find the total value of goods and services, final goods and services produced within a country, a certain boundary within a particular year. If you were able to calculate this, you'd find out GDP. The second method was the income approach. So if you could figure out the incomes generated by all the factors of production within a year, you'd come up with the GDP once again. And the last method was to actually calculate the total expenditure of incurred on final goods and services within a certain year, within a certain boundary. You would end up with GDP once again. This lesson is going to be focusing on how do we calculate growth in GDP. And when we want to talk about GDP growth rate, we want to focus specifically on how the productivity of a country changes over time. Which means we want to figure out how much quantity of things has the country managed to produce in a particular year compared to the previous one. Has there been an increase in production or a decrease in production? On the slide, you can see an example in which there is an economy which produces 10 cars in 2019 and sells them for 1 million each. And if you use the total output approach, you find that the total value of output produced by this particular economy was 10 cars into 1 million each. That would mean 10 million. This 10 million would be the total GDP of the country. In 2020, the country produces 10 cars but sells each of the car for 2 million. What's the GDP in 2020? So using the total output approach, 10 cars each sold for 2 million, and the total value of the cars produced in 2020 becomes 20 million. So that's your GDP in 2020. But has the productivity of the country increased or not? If you look at this slide, you see that in 2019, 10 cars produced. In 2020, still only 10 cars were produced. So has the GDP actually increased or not? Before we get into this detail, we want to talk about two kinds of GDPs. The first one is called nominal GDP, and the second one is called real GDP. So, what's nominal GDP? Nominal GDP is basically a GDP calculated using the current year's prices. For example, in the previous example that we just saw, in 2019, 10 cars were made. We used the same year's price, which was 1 million, and came up with the GDP of that year. This 10 million in 2019 is called the nominal GDP of 2019. In 2020, 10 cars were produced, and we used 2020's price, which was 2 million, and we came up with another value of GDP, which is 20 million. So this gives us the nominal GDP of 2020 because we were using current year's prices to find the current year's GDP. And the values of GDP that we were getting were called the nominal GDP. The production remained the same, however, since the prices changed, it caused the nominal GDP to increase. So what you need to take from this is that GDP can increase either because of a change in output or production or a change in prices. And this effect, the price and the output effect, is actually captured by your nominal GDP. But in the previous slide, we said that when we want to talk about GDP growth rates, we want to only focus on whether output increases or not. In this case, the normal GDP increases, but this increase is not because of the output, it's basically because of the price levels. To resolve this issue, uh, we use a different method to calculate GDP, and this GDP is called the real GDP. And what we do in the real GDP calculation is that we make sure that prices don't change across years, so we fix prices. And to fix prices, we assume constant prices for all the years. Now, the question is, which prices should we use? For example, in the case of Pakistan these days, when we're calculating the real GDP of 2020, we use the prices of the year 2015-16. And that year is our reference year. And that reference year is called the base year. For example, in our problem, if you were to calculate the real GDP, we'd say output of 2019 multiplied by the price of a car from the base year. So we're assuming that in this case, the price of the car in the base year is 1. So the GDP or the real GDP in 2019 is going to be 10 into 1, which is 10 million. This GDP now is the real GDP. Similarly, in 2020, output of 2020 multiplied by the price of the car from the base year. Base year is still 1 over here. So in 2020, since only 10 cars are produced and the prices remains the same because we fixed them, the GDP remains 10 million. So has the GDP increased? The GDP, the real GDP was 10 million in 19, 10 million in 2020. So the real GDP has not increased. There is no growth in productivity. There is no growth in GDP. However, if you were to look at the nominal values, you'd find that the GDP increased from 10 to 20, but this change was not because of productivity, it was because of price levels. So what you do is you fix prices, you make sure these prices don't change by using prices of a particular base year, which I assume to be 1 million over here. When I fixed the prices, I found out that the value of the GDP across the years is not changing because the productivity of the consecutive years is only 10 cars. You produced 10 cars in 2019, 10 cars in 2020. So that basically means that you did not increase your production or decrease it. Therefore, there is zero growth in the GDP. So we'll use an example to actually go through this again. But what we need to understand is that when we're talking about calculating growth in GDP, we have to use real values. By using real values, we are making sure that the prices are fixed and prices are not creating an increase in the GDP. Once the prices are fixed across the years, only a change in quantity can actually result in the GDP increasing or decreasing. So here's an example. This is from the book. So in this particular example, this economy produces two things: hot dogs and hamburgers. In 2001, 100 hamburgers were produced and 100 hot dogs were produced and 50 hamburgers were made. 2002, production of hot dogs increased from 100 to 150. Hamburgers increased from 50 to 100 to 100. Similarly, in 2003, production of hot dogs increased again to 200. Of hamburgers also increased from 100 to 150. We want to figure out how has the GDP of this particular economy that produces two things, hot dogs and hamburgers, increased over time. In order to do that, what you need to do is you need to calculate the GDPs for every year. So you need to calculate the GDP for 2001, then the GDP for 2002, and then the GDP for 2003. If you use the same year's price to calculate the GDP, for example, for 2001, you say 1 into 100 plus 2 into 50. So you're saying 1 into 100 plus 2 into 50, that gives you 200. So this 200 is the nominal GDP of 2001. In 2002, if you use the same year's 2002's price and multiply it by the quantity, and similarly the price of hamburgers and multiplied by the quantity of hamburgers, you come up with the GDP for 2002. But since you've used the same year's price, this is called the nominal GDP. So in order to calculate nominal GDP, what you do is you say 1 into 100 plus 2 into 50, that gives you nominal GDP for 2001. For year 2002, you say 2 into 150 plus 3 into 100, that gives you the GDP for 2002. This is the nominal GDP, which is 600. Similarly, for 2003, you calculate the GDP by multiplying 3 by 200, it's 600, plus 4 into 150, which is also 600. This gives you 1200 nominal GDP. So you come up with values of the nominal GDP. The second step is to calculate the real GDP. And if you note over here, when you were calculating nominal GDPs, the price of the hot dogs over time was changing, which is why the values of these nominal GDPs were inflated. To calculate the real GDP, which will make sure that the prices remain the same over years, we use the price as the base year. And the base year is your reference year, and you use prices of the reference year and fix it over time. So this one would get fixed over the next 2 years as well, and hamburgers would cost $2 for the next 2 years as well. Once you fix the prices, you calculate GDP again, and when you do that, so if you notice over here, hot dogs only cost $1 over the 3 years, and hamburgers cost $2 over the 3 years. You come up with different values from the last one. These were larger values because prices were actually changing, increasing over time. But if you make sure that the prices are fixed, you find that the real GDP was 200 originally, then it became 350, and finally 500. Once you have the values of the real GDP, the last step that you have to do is you need to calculate the growth rate of the real GDP to find out how the economy's production has been increasing or decreasing over time. And the formula for calculating the growth rate in real GDP is the GDP of the current year, which is Y2, minus the GDP of the previous year, which is Y1 over here, divided by the previous year, which is Y1, and multiplied by 100. So you say 500 is the current year minus 350, which is the previous year, divided by the previous year, which is 350, multiplied by 100. You come up with the value of real GDP growth rate. Similarly, for 2002 and 1, you use 2002 as the current year, 2001 as the previous year. So 350 minus 200 divided by 200 into 100. That should give you the real GDP growth rate of 2002. Notice over here that when you have 3 years available to you, you can only calculate 2 growth rates, because if you were to find the third growth rate, you need the previous year, which would be 2000, information of which is not available to you. So using this method, you can actually calculate the GDP growth rate. So just to recap, changes in nominal GDP can be due to prices changing or due to changes in the value of output. When we want to find out growth rate, we want to figure out whether the quantities of goods and services produced within a year has changed or not. And that is basically captured using the real GDP. Changes in the real GDP can only be due to changes in quantities produced because you've made sure that the prices are fixed. Let's go back to the learning outcomes. So the first learning outcome was to understand real and nominal. And we said that there are two kinds of GDPs. The first one is called the nominal GDPs, the second one is called the real GDP. The value of nominal GDP can change because of changes in price levels and changes in quantities of goods and services produced. However, for real GDP, a change in real GDP is only because of a change in quantities. And if you find out the growth rate of real GDP, you find out whether the production of a country has increased or decreased over time. We've talked about how to calculate GDP growth rate, and for that we've said in order to calculate GDP growth rate you need to calculate real GDPs and then use the formula y2 minus y1 over y1 into 100 to calculate the growth rate in real GDP. Only the growth rate in real GDP tells you how the economy is actually growing. Now we move on to the next part, which is to talk about inflation and the inflation rate. So inflation rates are basically persistent changes in price levels. And if you recall the previous problem that we just went through, you find that the price of things changed over years. What we want to figure out next is how expensive did hot dogs and hamburgers become over time. So we want to figure out how things in the economy became expensive. For that we want to figure out the inflation rate. So there are basically two methods to actually calculate inflation rate. The first one is calculating inflation using the deflator method, the GDP deflator method. And the GDP deflator is a measure of the price level calculated as a ratio of nominal and real GDPs multiplied by 100. So basically what the deflator is telling you is what is the difference between the nominal GDP and the real GDP, which is attributed basically because of a change in price levels. It tells us the rise in nominal GDP that is attributable to a rise in prices rather than a rise in quantities produced. So when we were talking about GDP growth rate, we wanted to figure out how the quantities changed over time, how the productivity changed over time. Now that we want to talk about inflation, we are not concerned with productivity anymore, we are concerned with price levels. And we want to figure out how the price levels change over time. And in order to calculate how much the prices changed over time, we calculate what is called the GDP deflator. It is an index and a measure of price level, and it's a ratio of nominal GDP and real GDP. And we will be using this index to actually calculate inflation rate. The formula for the GDP deflator is the nominal GDP divided by the real GDP into 100. So going back to the question that we did earlier, we calculated the nominal GDP when we were talking about GDP growth rate, although we did not need to calculate it. The main purpose of calculating the nominal GDP earlier was that we wanted to use the value of the nominal GDP to actually calculate the deflator later on. Although this was not required when you were calculating real GDP growth rate, but this is going to be important, it's going to be used when you're calculating the GDP deflator. So in this question we calculated the nominal GDPs and the real GDPs, and then we said that the real GDPs, the growth rate of the real GDPs is called the growth rate of the economy. It is the percentage change that you're told about. For example, in these days we're saying that the economy, because the coronavirus, is going to be growing at minus 1.25%. That's what IMF is saying, which basically means that production of the country is going to be decreasing. The quantity of final goods and services produced is going to be decreasing by 1.25%. Now we want to figure out how the prices of things produced in the economy changing over time. And for that, we calculated the deflator first. And the formula was the nominal GDP divided by the real GDP into 100. So 200 divided by 200 into 100. That gives you a deflator of 100. In 2002, you use the same formula for the deflator. The GDP deflator for 2002 is going to be the nominal GDP, which is 600, divided by the real GDP, which is 350 into 100. You come up with 171. And finally, for 2003, it's 1200 is the nominal GDP divided by the real GDP, which is 500 multiplied by 100, and that gives you a GDP deflator of 240. What you need to remember is that this value 100, 171 and 240 are basically indicating the price level, the general price level of things in the economy. And the growth rate of the deflator across different years would tell you how much this price level is increasing or decreasing over time. If it's increasing over time the way it is over in this question, it increased from 100 to 171. This means that things became expensive. By how much is actually called the inflation rate. So the growth rate of the deflator is actually called the inflation rate. So once you have the GDP deflators, you need to find inflation rate, and then the formula for finding inflation rate is the current year minus the previous year divided by the previous year into 100. So for 2000, inflation from 2002 to 2003, the deflator was 240, which is the present year, minus 171 divided by 171 into 100. Between 2002 and 2001, it was 171 minus 100 divided by 100 into 100. So 71%. So things became expensive by 71% between 2001 and 2002, and similarly you find a particular value of inflation between 2003 and 2002. So just to recap, in order to find inflation, you need to use the value of the nominal GDP and the real GDPs that you calculated to come up with values of the GDP deflator for every year. Once you have GDP deflator values for every year, you can find the inflation rate by calculating the growth rate of the GDP deflator over time. One thing to remember is that the GDP deflator does not have any percentage sign associated with it. However, the growth rate formula will have a percentage sign associated with it. In the next video, what I've done over here is I've left you a question that I'd like you to solve. However, with this question, I'd like to add that you need to calculate inflation rate as well. And once you've done it on a piece of paper, please take a picture of the solution and send it to me via email. Well, thank you.